Lagrange multipliers, part 4. This extreme value problem has a solution with both maximum and minimum values. Use Lagrange multipliers to find the extreme values of a function subject to a given constraint. Our function f of x, y, z is 6x plus 6y plus 3z. Our constraint equation is 3x squared plus 3y squared plus 3z squared is 27. So g of x, y, z is 3x squared plus 3y squared plus 3z squared minus 27. Del f is lambda del g. Del f is 663. Del g is 6x, 6y, 6z. Six, 6, 3 is lambda 6x, 6y, 6z. 6 is 6 lambda x, 6 is lambda 6y, 3 is lambda 6z, and 3x squared plus 3y squared plus 3z squared is 27. You can divide out of 3 here, obviously, you might have noticed that, so it's just going to be 3, it's gone, and this is 9. This is a sphere with the radius, I guess you could call, the distance is going to be 3 from the center to any point. I think people call that rho. We can think about that when we think about integrals in spherical coordinates. But yeah, it's basically a radial distance in a sense from the center to any point on the sphere. I'm not sure if that's called a radius, but I know that we use we use rho. So anyway, that's not important here. We need to do some algebra. So 6 is equal to 6 lambda x. We can divide by 6. 1 is equal to lambda x. And then 6 is equal to lambda 6y. I won't do some basic steps here. I just know that 1 is lambda y. And then similarly, if we divide by 6, we have 1/2 is lambda z. We can't equate all of these. However, what we can do is we can solve for lambda. So divide by x here, it's 1 over x. Divide by y here, it's 1 over y. And then, well, that is probably not the best idea to do. Let me actually do something else here. Let me do something else. We know that 1 is lambda x and 1 is lambda y. X can't be 0, y can't be 0 in order for us to get this. So lambda x is lambda y. What we can do is we can divide by lambda, so x is equal to y. So given this piece of information, what else can we do? Well, the next step for us is to look at this equation and work with it. So 3 is lambda 6z. And let's see here. So z is equal to, oh, okay, never mind. Let me just divide by 3. So 1 is equal to lambda 2z. Okay, I don't know why I didn't think about this earlier. Anyway, so this is going to be lambda 2z is either lambda y, lambda x, doesn't matter. We'll just do lambda x because I like to use x as our variable. And lambda, we can divide by lambda, so 2z is equal to x. That's what we wanted. This is important information. Okay, given all these things, we can think about our constraint. X squared plus y squared is plus z squared is 9. X is y, so we can just substitute y for x, so it's x squared. And then z is x by 2. If we divide by 2, so it's x by 2. That's what we know. So z is x by 2, so it's x by 2, and then squared is equal to 9. That's beautiful. So it's x squared. I'll just write it as 4x squared over 4 plus 4y squared over 4 plus x squared over 4 is 9. So we end up getting 4 plus 4 is 8, 9. So it's 9x squared over 4 is 9. Which means x squared over 4 is 1, x squared is 4, x is positive or negative 2. Since x is y, y is positive or negative 2. And then z is x over 2, or 2z is equal to x. So z is x over 2, we'll use that. So since x over 2, then z is equal to positive or negative 1. Possibilities. What are possibilities? Let's see. I'll write them here. So we have x and y need to be equal to each other. So we have 2, 2, and then z has to be x over 2. So, for example, in this situation, 2 over 2 is 1. So that's okay. And then next we have negative 2, and then x over 2, which is negative 2 over 2, which is negative 1. Anything else? Not really, no, because, like, think about it. If we have 2, 2, we can't have negative 2, 2, or 2, negative 2, so it has to be 2, 2. There's no other possibilities. This can either be 1 or negative 1. And so even if I write this here, 2, 2, if I do negative 1, that's not possible because 2 divided by 2 is not negative 1, it's 1. Similarly, if I did like negative 2, 1, that's also not possible. So it's just these two options that are possible given all our equations and stuff. So we can plug this in and get a value. F of xy is all of this, xyz is all of this. So f of 2, 2, 1 is 6 times 2 plus 6 times 2 plus 3, which is 12 plus 12 plus 3, or 27. And then this is actually negative 27. I won't solve it here, but you can think about it and solve it on your own. So your max is 27, and your min is negative 27. That's your answer.